Good evening to all. In previous lecture, I have taken the overview of the previous lecture. Then, in which classification of element classified into four types, that is linear and non-linear element, then active and passive element, then unilateral and bilateral element, and last one is time variant and time invariant system. Okay, this is the linear and non-linear element in which where characteristics follows only one equation of the straight line and passing through the origin, then this type of element is called as linear, otherwise non-linear element. Then active and passive element, that is active circuit means small amount of net power delivered to the load, then this type of circuit is called as active circuit. Okay, then the examples of active circuit is voltage source, current source and battery. Then the passive element examples are resistance, inductance and capacitance. When the value is greater than equal to 0, then this type of element is called as passive element. Then in circuit diagram, I have showing the active element and passive element. This is the concept of active and passive element. Then next one is unilateral and bilateral impedance or element. Okay, in which the bilateral metal in which impedance is same, also in which the direction of polarity like voltage and current also reverse, then both are same, then this type of material is called as bilateral element. Otherwise this type of material in which the polarity and direction are not same in reverse position, then this type of element is called as unilateral element. This is the concept of unilateral element. Then next one is time invariant and time invariant system, in which the VI characteristics changes with respect to time, then this type of element is called as time variant system. Otherwise, the VI characteristics does not changing with respect to time, then this type of element is called as time invariant element of the system. This is the classification of element. Then next one is classification of sources, that is classification of sources based on the dependent sources and independent sources. Okay, then in which independent sources based on voltage source and current source. Also voltage source depends on ideal voltage source and practical voltage source. Then another classification is current source, classified into two types, that is ideal current source and practical current source. Then second type is dependent sources, that is first one is voltage control voltage source, that is VCVS sources. Then second one is voltage control current source, that is VCCS. Then third one is voltage control voltage source, that is current control voltage source, that is CCVS. And last one is current control current source, that is CCCS. This is the classification of sources. Then first one is independent of sources based on the voltage source, then in which first one is ideal voltage sources. In ideal voltage sources in which load voltage is independent on load current in ideal voltage sources. And also second type in which practical voltage source, in which load voltage depends on load current, that means both are opposite to each other. That means this is the independent sources and this is the dependent sources. Okay, this is the classification of independent voltage sources. Okay, then second one is independent of current sources, that is independent sources classified into two types based on the current sources. Then first one is ideal current sources and practical current sources, in which the load current is independent on load voltage and load current depends on load voltage. That means this concept depends on independent sources and this concept depends on dependent sources. This is the overview of the current sources. Now second type is dependent sources, then in which the dependent source is based on the two types, that is dependent voltage source and dependent current source. Okay, then also dependent voltage source classified into two types, that is voltage control voltage source, that is this V1 controlled by this voltage. Okay, the second one is voltage control current source. That means V2 voltage controlled by current source. This is the type of the dependent voltage sources. Now second type is dependent current sources, classified into two types, that is current control voltage source and current control current source. Okay, in which the current I1 is controlled by voltage source, that is DC voltage source is shown in. Then in last one diagram, the current I2 is controlled by current source. This is the overview of the dependent sources. Okay, then this is the example of voltage control voltage source. This is the example of, that means V1 is controlled by, that is voltage control V1 is controlled by this voltage source, that is V1 controlled by V1. Also change voltage source V1 is replaced by V2. That means this is V2 voltage source controlled by this voltage source. Okay, this is the example of voltage control voltage source. Then second is voltage control current source, that is this voltage V1 is controlled by this current source, that is, okay, that means the value of P1 is put in this equation, that means the voltage control current source. This is the example of voltage control current source. Okay, now third one example is current control voltage source, the in circuit in which the current I1 is present, which is flowing from voltage source V1. Okay, this current controlled by this voltage source, that is DC voltage source. Okay, this is the example of current control voltage source. And last one is current control current source, in which also same example based on the third type, it is I1 controlled by this control source. Okay, that is current control current source. Okay, this is the last example of the current control current source. Okay, now next point is Kirchhoff current law. That is Kirchhoff current law based on the direction of current. That means direction of incoming current and direction of outgoing current, in which in any network in which the algebraic sum of the current at node is equal to 0, in which the rate indicated point is a node, then in which incoming current and outgoing current are present. Also in which the incoming current, that is sign convention used for current direction, that means incoming current use negative sign, then outgoing current use positive sign. Okay, then in which the current I1 is incoming current, then minus I1, then current I2 is outgoing current, take positive, that is plus I2, then current I3, that is incoming current, take negative sign, that is minus I3, then current I4, that is indicates incoming current, taken as sign is minus I4, and last one is current I5, that is outgoing current, taking plus I5. This is the equation of Kirchhoff current law. Now in which the negative sign current send left hand side, then obtain equation is I1 plus I3 plus I4, that is I1 plus I3 plus I4 is equal to I2 plus I5. That means this three current, that is I1, I3 and I4, is called as sum of the incoming current. That means sum of the incoming current is I1, I3 and I4, and sum of the outgoing current is I2 plus I5. This is the Kirchhoff current law based on the direction of current, like incoming current taken as negative and outgoing current taken as positive. This is the explanation of the Kirchhoff current law. Now next point is features of Kirchhoff current law. That means first is applicable for any lump circuit. Okay, then in which independent of nature of element, in which the Kirchhoff current law is applicable for dependent current sources as well as independent current sources. Then Kirchhoff current law follows law of conservation of charge, that is the rate of change of charge with respect to time. Then this type of law, then this law is called as law of conservation. Okay, now the basic equation of current is given by I is equal to the ratio of the change in charge with respect to time. That means I is equal to dq by dt. Okay, then this equation apply for current equation, then I1, that is dq1 upon dt plus dq3 upon dt plus dq 4 upon dt is equal to dq 2 upon dt plus dq upon dq 5 upon dt. Okay, that means current is I1, then current I3, then current I4, and current I2, and current I5. Okay, in the form of charge, the current in the form of charge is given by Q1 plus Q3 plus Q4 is equal to Q2 plus Q5. This is the Kirchhoff current law based on the rate of change of charge with respect to time. And the Kirchhoff current law also follows the law of conservation of charge. This is the overview of the Kirchhoff current law. Okay. Now next point is Kirchhoff voltage law. Okay. The in which the Kirchhoff voltage law, it is applicable for lump circuit, in which the statement of the Kirchhoff voltage law is the algebraic sum of the voltage around any loop or around closed loop is equal to 0. Then this type of law is called as Kirchhoff voltage law. Okay. Then features of Kirchhoff voltage law is applicable for any lump circuit or any lump network, then independent of nature of element, then follows energy conservation principle. Okay. Then this is the circuit of closed loop, then in which resistance, inductance, and capacitor are present. Then the voltage across resistance is VR, then voltage across inductance is VL, then voltage across capacitor is VC. Now apply Kirchhoff voltage law. Take addition of three element, that is then minus V. Okay, then current direction is showing. Okay, then current is flowing from voltage to other element. Okay, then voltage is minus, plus voltage is VR plus VL, because taken negative sign for minus V, because current direction show is clockwise, then voltage sign is VR is positive, then take positive, then voltage sign VL is positive, then voltage across capacitor VC is positive, then minus V is shift right hand side, then obtain the equation of Kirchhoff voltage law is V is equal to VR plus VC plus VL. Okay, then the Kirchhoff voltage law applicable for or follows energy conservation principle. Then voltage is equal to the rate of change of work done divided by charge. Then this type of concept is called as Kirchhoff law based on the work per charge. Okay, then the dW upon dQ, that means work upon charge, is equal to for resistance, inductance, and capacitance, is equal to dWr upon dQ plus dWl upon dQ plus dWc upon dQ. Okay, in the form of work done, that is energy. Energy is equal to W is equal to WR plus WL plus WC. Okay, then W indicates that energy transfer to the circuit or element, then WR plus WL plus WC called as energy absorbed. That means the Kirchhoff voltage law based on the energy conservation principle, in which the concept is identical, that means energy transfer is equal to energy absorbed. This is the basic concept of Kirchhoff voltage law based on the loop or closed loop or mesh. Okay, mesh loop. Okay, this is the concept of Kirchhoff voltage law. Okay, now series connection and parallel connection. Then we have explained the concept of series connection. Okay, then in which there are two impedances are connected in series, that is Z1 and Z2. The supply voltage, DC supply voltage is V, then current flowing through circuit is I. Okay, then voltage across impedance Z1 is V1. Okay, then voltage across J2 is V2 are shown in figure. Now we have to find out equivalent impedance, that is Z equivalent, that is equivalent impedance. Impedance is equal to, that is Z is equal to R plus JX, that means the addition of resistance and imaginary part of the inductance. This is called as impedance of the network. Okay, then Z equivalent is equal to Z1 plus Z2. Now put Z1 is equal to resistance R1 and Z2 is equal to R2. Then next equation is obtained is equivalent resistance, that is R equivalent is equal to R1 plus R2. Now put Z1 is equal to XL1, that is in inductance. Okay, that is Z1 is equal to XL1, then Z2 is equal to XL2. Then equivalent reactance is given by X equivalent is equal to XL1 plus XL2. Then in the form of energy, that is W equivalent is equal to WL1 plus W2. Then equivalent inductance is given by L equivalent is equal to L1 plus L2. That means the series connection is applicable for any closed loop circuit in which addition take place of the element. Then this type of series connection is in which the current is remains same and take the addition of the element. Okay, now equivalent capacitance is given by Xc equivalent is equal to Xc1 plus Xc2. Okay, then X is equal to 1 upon omega C in the form of capacitor. Then 1 upon omega C equivalent is equal to 1 upon omega C1 plus 1 upon omega C2. Okay, this is the concept of impedance, resistance, inductance in the form of work done inductance and equivalent capacitance. This is the series connection with respect to impedance. Now in also this circuit diagram also same as taken in which then apply KVL, then obtain the minus V. Okay, then current direction in anti-clockwise, then current flowing from this path I to this path. Okay, then minus V, then plus V1 plus V2 is equal to 0. Then obtain total voltage of the circuit is V is equal to V1 plus V2. Then impedance Z is equal to V upon I. Okay, then V1, consider V1 is voltage V1, then voltage V1 across Z1, then V1 is equal to I into Z1, then put I into Z1 for similar voltage V2 for impedance Z2 plus I into Z2. Then in which the I is taken as common, then I is equal to obtain the equation is V upon Z1 plus Z2. That means current flowing through the circuit is the ratio of supply voltage upon addition of the impedance. Okay, this is the current equation of this circuit, that is I is equal to V upon Z1 plus Z2. Now in next equation find out voltage V1 and voltage V2. Then in with respect to voltage phi, then firstly we have to find out voltage V1 with respect to voltage V. Then V1 is equal to V into, that is V into Z1 upon Z1 plus Z2, that is voltage across Z1 is V1, that is V1 is equal to V into Z1 upon Z1 plus Z2, because we have considered impedance V1, then it is the ratio of Z1 upon Z1 plus Z2. This is the voltage V1 across impedance Z1. Now also voltage V2 for impedance Z2, that is V2 is equal to V into bracket Z2 upon Z1 plus Z2. The in circuit in which 4 parameter is very important. First one is voltage V, find out, then also find out current I is equal to, then also find out voltage V1 is V1, and last one is voltage V2. This is the combination of series connection with respect to series impedance. Okay, then also in which the impedance in the form of resistance, inductance and capacitance. Okay, then similar diagram, then in which consider Z1 is equal to R1 and Z2 is equal to R2. Okay, then find out voltage VRL from this resistance R1. Then VR1 is equal to V into bracket R1 upon R1 plus R2. Then we have considered Z2 is equal to R2. Then voltage VR2 is equal to V into R2 upon R1 plus R2. For consider Z1 is equal to R1 and Z2 is equal to R2. Then also consider Z1 is equal to L1 and Z2 is equal to L2. Then find out the voltage VL1 is equal to V into bracket L1 upon L1 plus L2. That means this is Z1 is equal to put L1 and Z2 is equal to put L2. Then VL1, that is voltage across inductance L1 is VL1 is equal to V into bracket L1 upon L1 plus L2. Then also find out voltage across inductance is VL2. Okay, then VL2 is equal to V into bracket L2 upon L1 plus L2. Then also find out capacitor, that is put Z1 is equal to C1 and Z2 is equal to C2. Then voltage across capacitor is VC1 is equal to V into bracket C2 upon C1 plus C2, in which the capacitance is reciprocal, that is X is equal to 1 upon 2 pi FC. Then we have taken C2 upon C1 plus C2. Then this is the voltage across capacitor C1. Then VC2 is equal to V into bracket C1 upon C1 plus C2. Okay, this is the concept of series connection based on the impedance, then Kirchhoff voltage law and voltage across impedance. Okay, then next is parallel connection. Okay, the parallel connection in which the two impedances are connected in parallel. That means Z1 and Z2 both are connected in parallel. Then in which supply voltage is DC. Then DC voltage is applied to the circuit. Then current I is flowing through the circuit. That is current I, voltage is applied, the current I is flowing at that instant in which one node is present. Okay. Then the function of node is used as to distribute current in the form of more branches. Okay. Then node distribute current, that is I1 flowing from Z1 and I2 flowing from Z2. Then voltage V across Z1 and voltage V across Z2. Now also put impedance Z1 is equal to R1 and Z2 is equal to R2. Then find out equivalent resistance, that is R equivalent is equal to R1 into R2 upon R1 plus R2, because both resistance are parallel. Then R equivalent is equivalent resistance obtaining is equal to R1 into R2 upon R1 plus R2. Now also put Z1 is equal to XL1 and Z2 is equal to XL2. Now find out equivalent inductance is equal to L1 into L2 upon L1 plus L2. Okay. Now again put impedance Z1 is equal to XC1 and Z2 is equal to XC2. Then equivalent capacitance is equal to C1 plus C2. Okay. Then also in which find out current I1 and current I2. Okay. Then current I1 is given by I1 is equal to, that is current flowing from I1 from impedance Z1. Then I1 is equal to supply voltage V upon Z, that is impedance is Z1. But V is equal to IZ. That means V is equal to IZ formula put in, that is I into Z equivalent. Okay. Then I into Z equivalent upon Z1, but Z equivalent in the form of R equivalent. Then Z equivalent is equal to Z1 into Z2 upon Z1 plus Z2. Then Z1 get cancelled. Okay. Now obtain the current equation for I1 is equal to I into bracket Z2 upon Z1 plus Z2. That means this current flowing from I1. Then also obtain equation for I2 is equal to I into bracket Z1 upon Z1 plus Z2. This is the equation of I1 and I2. Okay, then also parallel connection obtained for equivalent impedance in which current flowing through it. Okay, then same circuit diagram used for each concept. Then put Z1 is equal to R1 and Z2 is equal to R2. Okay, then current flowing through for impedance Z1 is equal to R1, then current flowing through is R1 is I into R1 is equal to I into R2 upon R1 plus R2. Or similar, I R2 is equal to I into bracket R1 upon R1 plus R2. Okay, this is the current flowing from resistance R1 and resistance R2. Okay, now again put Z1 is equal to XL1 and Z2 is equal to XL2. Now obtain the current flowing from inductance L1 is equal to I L1 is equal to I into bracket L2 upon L1 plus L2. That means put Z2 is equal to L2 and Z1 is equal to L1. We have considered I L1 is equal to I into bracket L2 upon L1 plus L2. Now again find out current flowing through impedance L2 is I L2 is equal to I into bracket L1 upon L1 plus L2. This is the current flowing from inductance L1 and L2. Okay. Now again find out current flowing through capacitance, that is Z1 is equal to Xc1 and Z2 is equal to Xc2. Okay. Now obtain the current flowing from capacitor C1. IC1 is equal to I into bracket C1 upon C1 plus C2. That means put Z1 is equal to C1 and Z2 is equal to C2. Then obtain the current flowing from capacitor C1 is IC1 is equal to I into bracket C1 upon C1 plus C2. Now also another current find out IC2 is equal to I into bracket C2 upon C1 plus C2. Okay, this is the current division rule using for resistance, inductance and capacitors. Okay, this is the combination of series connection and parallel connection. Okay, this is series connection also in which find out equivalent impedance with respect to resistance, inductance and capacitance. Also KVL apply for this circuit, then obtain the voltage V1 and V2. This is the series connection. Also find out series connection in which voltage across resistance, inductance and capacitor, that is VR1, VR2, VL1 and VL2, VC1 and VC2. Okay. Then in parallel connection in which find out equivalent resistance, equivalent inductance, equivalent capacitance. Then also find out current I1 with respect to impedance, that is I1 is equal to I into bracket Z2 upon Z1 plus Z2. Then parallel connection in which find out equivalent impedance with respect to Z1 and Z2. Then put Z1 is equal to R1 and Z2 is equal to R2. Then find out current flowing through resistance R1 and resistance R2. Then again similar, put Z1 is equal to L1 and Z2 is equal to L2. Then obtain the current flowing from inductance L1 and L2 is IL1 is equal to I into bracket L2 upon L1 plus L2. Then IL2 is equal to I into bracket L1 upon L1 plus L2. Now again put Z1 is equal to Xc1 or C1, then Z2 is equal to Xc2. Then obtain IC1 is equal to I into bracket C1 upon C1 plus C2 and IC2 is equal to I into bracket C2 upon C1 plus C2. This is current division rule. Okay. Now last point is mesh analysis. Okay. Then mesh analysis in which the closed loop circuit is very important to find out current flowing through closed loop circuit. Okay. Then in which the voltage source required for the mesh analysis for input side as well as output side. Okay, then in which voltage source is not present, then mesh circuit or loop circuit does not operate. Okay, in which the mesh circuit require AC voltage or DC voltage as per your requirement. Then circuit diagram is shown in figure, in which there are two voltage source, that is 12 volt for input side and 5 volt for output side, in which there are three resistance, then 2 ohm resistance also parallel to the 2 ohm resistance, and this 2 ohm also parallel to the 4 ohm resistance, that is which are required to find out equivalent resistance. Then the in which consists of two loop, that is this is loop 1. Okay, and this is another loop 2, that is loop 1 and loop 2. The loop in which the current I1 is flowing through it, that is current I1 is shown in. Then also in which the loop second, in which current I2 is flowing, that is the direction of current I1 and I2 is clockwise direction. Okay, then in which to find out current. Okay, then current we have considered loop 1. Okay, then apply Kirchhoff voltage law in mesh 1, that is mesh 1 means this mesh 1 or loop 1, that is the main principle of Kirchhoff voltage law is algebraic sum of the voltages in closed loop is equal to 0. Okay, then apply KVL for mesh 1. Then we have considered 2 ohm in which current flowing is I1, that is 2 into I1 plus 2 ohm resistance, in which current I1 is flowing from positive direction and current I2 flowing from negative direction. Then taking difference, that is I1 current flowing is I1, and then current flowing is for I2, that is I1 minus I2 for 2 ohm resistance. Okay, that is 2 into bracket I1 minus I2. Then voltage is minus 12. Okay, that means obtained equation is 2I1 plus 2 into bracket I1 minus I2 minus 12. Okay, then 12 is shift right hand side, then obtain the equation is 4I1 minus 2 into I2 is equal to 12. Then 2I1 minus I2 is equal to 6. Equation number 1. Now mesh consider second. Okay, then apply KVL. Okay, that is 4I2 plus 5 plus 2 into bracket I2 minus I1 is equal to 0. Then obtain equation is, then in which minus 2 I1 plus 6 I2 plus 5 is equal to 0. Now from equation 1 and 2, then obtain the two values of current, that is I1 is equal to 31 upon 10 ampere, then I2 is equal to 1 upon 5 ampere. Okay, then we have concluded that, or we have observed that the current I1 is greater than I2 because the voltage also greater than 12 volt is greater than 5 volt. Then in which obtained current is I1 is greater than I2, that is I1 is equal to 31 upon 10 ampere, and then I2 is equal to 1 upon 5 ampere. Okay, that means current I1 is greater than I2. Also in which find out current I, that is current I is equal to I2 minus I1, that is I is equal to I2 minus I1, that means put the value of I2 is 1 upon 5 minus the value of I1 is 31 upon 10, that is 1 upon 5 minus 31 upon 10, then obtain the total current of the circuit with respect to 2 ohm resistance is minus 29 upon 10. Okay, this is the mesh analysis. It is very important, required for the GATE exam. Okay, also in which the series connection and parallel connection is very important. Also Kirchhoff current law is very important for the solving the problem regarding network circuit. Okay, this is the overview of the mesh analysis, then series and parallel connection, then classification of sources and classification of element is very important. Okay, then any questions regarding mesh analysis, parallel connection, series connection, Kirchhoff voltage law, Kirchhoff current law, then dependent sources, independent sources, that is the classification of sources and classification of element. Any questions from students? Then ask. Any questions? Any questions from student side? Okay. Then I have sent feedback link. Then all student fill feedback for regarding get lecture. That is, then I have shared link. Then all student fill feedback form regarding get lecture. Any questions regarding this topic? That means today's I have covered the concept of voltage source, current source, that is dependent source and independent source. Then resistance, inductance, capacitance elements in the form of series and parallel connection. Then also I have complete Kirchhoff current law, Kirchhoff voltage law, also mesh analysis with respect to node. Then next lecture we have conclude next lecture based on Thevenin's theorem, Norton theorem, superposition theorem, and maximum power transfer theorem. Okay. Also, transient response of DC network and AC network. Okay. This is the syllabus of the electrical circuit. Okay. Only 5 points are pending. That is network theorem, transient response of DC network, then two-port network, and star delta transformation and complex power. Okay, this is the syllabus of the electrical circuit. Feedback form is open or not? The feedback form is directly click on link, then form is open. That is electrical circuit get lecture second. Then your name, then your roll number, then your category is fill, then your class and name of the faculty. Then today's session was informative, yes or no, or maybe. Then you have take out of 10 marks regarding get lecture, and any suggestions then send me. Then next lecture I will try for improve. Okay, then all students fill. Then also I have shared PPT or notes on Google Classroom. Then also I have shared notes on Google Classroom. Any questions regarding classification of element? That is linear and non-linear element. Any questions regarding where characteristics of elements? That is linear and non-linear. Then active and passive element. Any questions regarding this topic? It is very important for solving the problem in GATE exam. It is active and passive element. Any questions? Then unilateral and bilateral element. Any questions regarding this topic? Then ask. Is unilateral and bilateral element. Any questions? Then time variant and time invariant system. This is the numerical based on the nature of element. That is linear and non-linear, bilateral, unilateral, then active and passive element, and last one is time variant and time invariant of the system. Then classification of sources. Any questions regarding classification of sources, that is independent sources and dependent sources based on the current sources and voltage sources? Any questions regarding independent sources, that is ideal voltage source and practical voltage source? Then current source, ideal current source and practical current source. Any questions regarding independent current sources, that is ideal current sources and practical current sources? Then dependent sources. Any questions regarding dependent sources? Please ask. That is voltage source and current source. That is Kirchhoff current law. Any questions regarding Kirchhoff current law? It is very important to solve electrical circuit problem or electrical network problem in open loop or closed loop circuit in GATE exam. It is Kirchhoff current law. Any questions regarding statement, explanation and features? Any questions regarding Kirchhoff current law? Then Kirchhoff voltage law. Regarding statement, explanation and features of Kirchhoff voltage law. Any questions? Also regarding concept of energy conservation with respect to energy transfer and energy absorb. Any questions? Then concept of series connection and parallel connection. Any questions regarding series connection with respect to impedances like resistance, inductance and capacitor to find out equivalent impedance? Any questions regarding series connection? Also parallel connection. Then last one is mesh analysis. Okay. Then you can leave the meeting. Also fill feedback form. Okay. Any suggestions regarding lecture? Get lecture. Then tell me any suggestions regarding get lecture to improve get classes for T and BA students. Okay, thank you. Then you can leave the meeting.